Welcome to Omega Virtual Learning. In today's lesson, we'll be talking about box plots. And we will talk about how to draw box plots from raw data and also how to compare box plot and make valid conclusions. Now let's look at some features of box plot. This is a box plot and this is a typical example. Let's look at the first one. Box plot make use of 5 main calculations. We make use of the smallest number or the least number in the data, the lower quartile, which is normally called the first quartile, the median, the upper quartile, which is also called the third quartile, and the maximum or the biggest number. And the gap between the lower quartile and the upper quartile is what we call the interquartile range. Using a formula, you can just work it out by subtracting the lower quartile from the upper quartile. We'll talk more about it in our calculations. This is a typical example of a box plot. You could say the maximum number is 13, the upper quartile here is 10, the median is 8, the lower quartile is 5, the smallest number is 0. And if you want to work out the interquartile range, is 10 minus 5, upper quartile minus lower quartile, and that will give you 5. Now, one thing I want you to understand is that box plot, the calculations that we've made mention of, we use it to divide the data into quarters, as you can see. From the minimum to the lower quartile is a quarter. Lower quartile to the median is also another quarter. Median to upper quartile, then another quarter. Upper quartile and the maximum another quarter. So you divide it into quarters. But it doesn't mean there has to be exactly a quarter on a line. All it's trying to tell you is that the data is divided into quarters. The data is put into quarters. The range of the data is put into quarters. So that is a quarter. From this point to the median is half, because 2 quarters is equal to half. From the minimum to the upper quarter is 3 quarters. 3 quarters. Now let's see how to calculate box plot value, the calculations for box plot from raw data. We're going to consider 2 situations where we have set of raw data and the observations in the data is odd. We see what happens, and where the observation of data is even. So let's start with the odd one. So here we have ages of 13 passengers on a bus, and these are the ages. And if you can recall the 5 main things that we're going to calculate, median is one of them. And the moment you want to work out median, you need to put your data in order, because the definition of median is the middle data of an ordered data. You cannot just pick the middle number if the data is not in order. So first is we put the data in order. So that's what we've done now. Now we can work out the median. The easy way to work out median is cross from both ends one by one until you get to the middle, because you want to know the middle number. So you can use this technique by crossing until you get to the very middle. So you can see I have 11 as our middle number, so median is now equal to 11. Now one interesting aspect of this is that the moment you work out the median will split the data into 2 halves. Median will always split the data into 2 halves. So we have the first half, then we have the second half. Now it's very interesting that whenever that happens, you can easily work out the median of the first half, and that will stand for your lower quartile. You can also work out the median on the second half, and that will also stand for the upper quartile. So let's see how to calculate that. So we're going to work out the median on the first half, cross from both ends until we get a middle number. Now realize that here we don't have a single middle number, but rather we have 2. Whenever you have 2 middle numbers, all you need to do is work out the average of the 2, and that will represent the median. So you're going to work out the average of 5 and 7. 5 plus 7 divided by 2, that gives us 6. So our median for the first half is 6, but this median represents the lower quartile. Don't get confused. It's median for the first half, but it represents the lower quartile. We are now going to work out the median for the second half for our upper quartile. The same principle. Also 2 middle numbers, so work out the average, add and divide by 2. So we know our upper quartile is 22. Now from the data you can see easily your smallest number and the biggest number. So I have my smallest and the biggest done. So my 5 main calculations that I need for the box plot is now calculated. 3, 6, 11, 22, 27. Now, like I said, we must put the data into quarters. Let's check. You can see 1, 2, 3. That's a number. 1, 2, 3. That's a number I'm using. 1, 2, 3. That's a number in that order. So this is definitely a quarter, first quarter, second quarter, which is the median, the third quarter. Let's put it on the graph then. So smallest is 3, lower quartile 6, median 11, upper quartile 22, the largest or biggest 27. Then all you need to do is that the upper quartile and the lower quartile will make a box, and you just join the lower and the maximum or the biggest number with a straight line to the box. Simple as that. So remember, the box represents the interquartile range. The box represents the interquartile range. Okay. So if you want to even work out the interquartile range, it's simply the value here, which is 27 minus 6, and that gives you your interquartile range. Second example is where we have the observation in data is even. Let's put it in order as usual. Let's work out the median. We cross from both ends. Here there is no single number, so we work out the median by working out the average of 12 and 16. That gives us 14. Now, that also split the data into 2 halves. Now remember, the 14 is not part of the data. This 14 is not part of the data. So when it's split into 2, one half will start from 12 all the way down. The other one will start from 16 all the way up here. The first one that we saw, it was different because the median was actually in the data and that was circled out. So what didn't belong to any of the sections. Let me take you back to make sure you understand that. So you see, this median doesn't belong to any of the halves. It's on its own. So when you circle it as a median, it doesn't belong to any of the halves. But when we come to this one, you realize that the median is not part of the list of numbers that you have. So you need to know that when you divide it into 2, it starts from this point all the way down for one half, and the other half from 16 all the way up. So you need to be very careful of that. That is why I'm giving you these 2 examples. Okay, so this is it. Let's work out the median for the first half for our lower quartile. So it's 7. Let's work out the median for the upper second half for upper quartile. 21. Okay. Now remember, we had 14 for our median, and our smallest is 2, largest 29. So let's plot them on a graph. So this is our graph. So this is how we get our values to draw box plot from raw data. We're now going to see how do we compare box plot. How do we compare box plot? Don't forget, if we're asked to work out the interquartile range, upper quartile minus lower quartile. Okay, before we do the comparison, how do we get box plot when we have some of the values given and some missing and we need to work it out? This is a typical example. From 5 students in Swiss, we had a test. The lowest mark was 20, highest mark 88, median 54, lower quartile 34, interquartile range 40. So let's see the information and see which one is missing and which one you've been given. We know our lowest, we know our highest, we know our median, we know our lower quartile, but we don't know our upper quartile. What we have here is interquartile range. And if you recall what I explained to you about interquartile range, is the gap between the lower quartile and the upper quartile, which is the same as upper quartile minus the lower quartile. So given the interquartile range, let's use the formula. If upper quartile minus lower quartile equals interquartile range, then upper quartile should be equal to interquartile range plus the lower quartile. You make upper quartile the subject of the formula. So by changing it around. So we know upper quartile is the interquartile range plus the lower quartile. So all we need to do is, we know our interquartile range is 40, and we know our lower quartile is, interquartile range is 40, and our lower quartile is 34. So that gives us upper quartile 74. So what we need is 74, and that's what we've calculated. Put it on the graph. 20 smallest, 88 highest, 54 median, 34 lower quartile, 74. Now use the lower quartile and the upper quartile to make the box. And that is what you've done. Be careful with your scales. It goes up in 2. Check your scale before you draw. It goes up in 2. Okay. Now, comparison. How do we compare? Example. Below are box plots of goals scored by players from two teams. So we have team A, team B. So the goals from 2 teams is used to create this box plot. We are supposed to make a conclusion as to which players from which team are really, really reliable to be featured in a match. Okay. When you are asked to actually compare data, the first thing you need to talk about is the median. The second is the interquartile range, and possibly use range where necessary to talk about the variability of the data. So first, important, median, interquartile range, and range. So by talking about median, interquartile range, and range, you talk about all the 5 automatically. Because if you want to talk about the range, you are talking about the maximum and this minimum number. If you want to talk about the interquartile range, is the lower quartile and upper quartile that you are using to calculate. So it's simply much the same as talking about the whole thing. So let's see. You see that team B median is bigger than team A. What does it mean? We'll come to that in a minute. Also, team B's interquartile range, as you can see, is bigger than team A. Let's talk about the range. You can also see that the range of B is bigger than the range of A. So you can see every aspect that we see here, median, interquartile range, and range of B is bigger than A. Okay, so this is just a statement that we just made. Now let's see the implications or the contextual meaning of these. Whenever median is bigger, so in this case, team B's median is bigger than team A. That means that on average, players from team B score more goals than team A. On average, median is a type of average. So on average, the goals from team B are more than goals from team A. When you talk about the interquartile range, it means that the middle 50% of the data is more varied. So there's more variability in the data of the middle 50%. In that case, it means that it makes the median not reliable for team B. So whenever interquartile range is too wide or too big, it makes the median not reliable. The smaller the interquartile range, the better is the median. So here we can say that team B's interquartile range is bigger than team A, and that means that the median for team B, though bigger than A, is not reliable. It's not really consistent with the data. But this median for team A is more consistent with the data. Also, the range of B is wider, meaning that the data in team B is more varied. The variability is wide in team B than team A. So it means that one day a player could score 1, the next day could score 7, the next day could score 2, the next day could score 8. It's so varied. But team A is more consistent in terms of the variability. So note, the bigger the interquartile range, it makes the median not consistent. So the smaller the interquartile range, the better and the more consistent is the median. The smaller the interquartile range, the more consistent or better it is the median to represent the data. Now let's look at a situation where we have both median the same. So here you see boys median the same as girls. Interquartile range for boys bigger than girls. Now if you want to explain, and range is boys bigger than girls. Now here, because they are the same, on average it seems to be performing or scoring the same marks on average. Now that's one of the reasons why we might need to use the interquartile range. The boys' interquartile range is bigger, making their median not consistent. So we can say that the median for girls is more consistent than the boys because the interquartile range is smaller. And there's more variability in the boys' data because the range is wide. So the data is more varied compared to the data of the girls. So the rule of thumb here is that the smaller the interquartile range, the better it is for the median to represent the data, or the more consistent it is for the median to represent the data. So that brings us to the end of lesson on box plot and how to compare box plot. Hope you've enjoyed it. Please share with your friends and subscribe to the channel so you can, and hit the notification button so you can get notification of new videos that I post. And if you are new to this channel, you are welcome. Please subscribe. Thank you very much.